All right, homework number whatever this is. I want to make sure that we're going through the problems and having them solved in a way that makes sense to all of us. So first, we want to determine the average velocity of this object given the position versus time graph. Well, that is 100% the slope. So I'm going to use v naught as the letter for velocity, but I'm going to be clear here that I have this point 6, 60, and here the point is 0, 10. Now some of you may look at this and just say, oh, by reading the rise over the run is 1 and the rise is 10, and you might say that v naught is 10, but let's be really clear. I'm going to actually use the rise over the run by taking 60 minus 10 over 6 minus 0, and this actually gives me 50 divided by 6. And when we actually put that into our calculator, it gives us something a little bit under 10. It actually gives us 8.3 meters per second. And then when it says write a mathematical expression to describe the motion of the object, now if this were algebra class, we would say y equals mx plus b, and we'd want the equation of the line, and I would say y is 10 times x plus, 8.3x, the slope, plus b, which is 10. But that's not how we do this in physics. We want to be really clear that we're talking about a real physical object. So its position is given by the velocity times the time plus the y-intercept, which is where it started. And for us, that's going to be x equals 8.3 times t plus the initial position of 10. Now, we have a velocity versus time graph for this object, and we want to describe its motion. So let's be really clear. From 0 to 2 seconds, it moves. Now look at this velocity. It's 4, which means positive, so it moves forward at 4 meters per second for 2 seconds. Then it goes backwards, or opposite its original motion, at 3 meters per second. We can be clear and say at negative 3 meters per second for 1 second. And then it comes to a complete stop. Because for 3 to 5 seconds, it's not moving because the velocity is 0. Now, we want to draw the appropriate velocity or position versus time graph. So let's just remember, we learned in class, remember, velocity is the slope. So the velocity graph above is the slope of the graph below. So here's what that means. For 2 seconds, I'm going to have a slope, and then I'm going to actually label these axes. Let's go ahead and do that, in fact. So we'll make this 2 seconds, 4 seconds, 6 seconds. Great. And then here we're going to have 2, 4, 6, 8, like that. So for the first 2 seconds, it looks like our slope is 4, so we're going to go over 1. Sorry, let's try this again. We're going to go over 1 and then up 1, 2, 3, 4. Over 1 and up 1, 2, 3, 4. That's the whole point here, is we'll actually draw a graph that does this. Then we go backwards at 3 for exactly 1 second. And let's be clear, that's at, the slope here is negative 3, so we'll go over 1 and down 3. And then we're told the object stays at rest. So that means from 3 to 5 seconds, the object sits here perfectly still. So that's the idea, is that this graph, the slope of this graph is 4, the slope of this graph is -3, and then the slope of this last part is 0. So that's page 1 of the homework, and we'll take a look at page 2 in the next video.